Hello everyone. We are now into the next lecture, and I hope that you have done some practice related to the tables of 2 digits and 3 digits. And if you practice, you will feel comfortable, as the time progresses. And also, you will have the idea about the numbers. Once you see certain numbers, you will have certain idea that what are the factors of these numbers. So once you read tables, so basically they are nothing but so suppose you are reading the table of 29 into 5, that is 145. So if you see the number 145, immediately it should strike in your mind that it is a factor, its factor is 5 and 29. So that is the main concept of reading the tables, and as soon as you see the numbers, and if you develop that interest, that by looking at the numbers, what kind of factors it has, so by which it will be completely divisible, and so that's why reading tables are important, and once you read the tables more frequently, you will be comfortable. Now in this lecture we are going to have the concept of the divisibility of numbers. So once you read the tables, or you know the factors, that is nothing but that gives you concept of divisibility. So but it is somewhat different. Divisibility means any number is divisible by certain number or not. So like 145 is divisible by 5 because 5 is at the unit place. Similarly, 27 is it is divisible by 3, not by 2, because 2 is an even number and any odd number cannot be divisible by 2. So this way you have certain rules that you are taught. But apart from that, we will also discuss about some special things, which is the concept of also remainder, by which we try to know that how to find whether this number is divisible by 359 or not, how to find that some number is divisible by 17 or not. So for that, there is a concept of remainder number also. So that is based on the remainder theorem. So certainly that is understood at high level, but its raw version can be understood by us. So we'll talk about it. So coming to suppose the concept of divisibility. So what we will see is that we will go to a white screen, and then we will see the numbers. So divisibility we have to check, and as we will start with the numbers. So that if any number has to be divisible by 2, so by 2 means number has to be even. Okay, so it means at unit place you think that you must have 0, 2, 4, 6 and 8. Similarly, by 3, you know that for the number to be divisible by 3, add digits and then check whether it is divisible by 3. Okay, so if the number is divisible by 3, if adding the digits, if it is divisible by 3, so suppose you have numbers like 5, 8, 7, 2, 3. So you add them, you can remove 3. So 5, 8 plus 8, 15, 13 plus 7, 20 plus 2, 22. It's not divisible by 3. But if you add 2 here, then it will be divisible by 3. So that way you check whether it is divisible by 3 or not. Then comes by 4. So by 4 means it should be an even number, but the thing is, in this the condition is that last 2 digits should be divisible by by digit should be divisible by 4. So that way, you can understand the concept of divisibility by 4. So last 2 digits you have to check, then only. So similarly, if you go to by 8, by 16, by 132, like that, so it will be going that way. Last 2 digits has to be seen. Last 2 or 3 or 4 or 5, it will go away, like that. Then comes by 5. So by 5, you know that last digit has to be 5 or 0, either 5 or 0. Then comes 6, by 6. So by 3 and even number. So first of all, you have to see that it is by 3 and then it should be an even number. Then go to by 7. Now by 7, actually we will talk about the rule that is your remainder theorem. So for that we will go for that. And then by 8, so last 3 digits should be divisible by 8, or even if the last 2, see, if the last 2 digit is divisible by 8, then the third digit, I mean the 100th place digit, has to be an even number, then it will be divisible by 8. Or else if the last 2 digit is divisible by 4, so like this, like see, if you take, so if you say 24 is divisible by 8, but third digit must be even number. So if it is even number, then it is divisible by 8. But if it is an odd number, it is not divisible by 8. So keep it 2 or 4 or 6 or 8, it will be divisible by 8. But if this is last 2 digit is divisible by 4, suppose say it is 12. So if the last 2 digit is divisible by only 4, then here the even number has to be there, then it will be divisible by 8. So this number has to be odd number. So these are the rules by which you can understand that whether this number will be divisible by 8 or not. So if so, what we understood that in this case, this is divisible by 8. Only that last 2 divisible by 8. But in this case, this only is divisible by 4. So many times you get this number, 2-digit number, which is divisible by only 4. But if the third digit is even, odd number, then it will be divisible by 8. Then we will be going to the next whiteboard. So further, you must be knowing about the divisibility by 9. So in the divisibility of 9, you might be knowing that add the digits, and if it is divisible by and if divisible by 9, then it is divisible by 9. Okay, so you can say that 5, 8, 2, 3, it is divisible by 9. You go to any number 8, 73, add them, it is divisible by 9, so it is divisible. So 8 plus 7 plus 3 is 18, so it is divisible by 9. Here 13 plus 2, 15 plus 3, 18, divisible by 9, like that. Now coming to another concept, that is using the remainder theorem, using remainder concept. Now in that we try to have the generalized concept. Before that, there is another, you must have heard that for divisibility by 11, so in divisibility of 11, you can see what we do is that we add the alternate numbers and then we take a division, a difference of them. Okay, so suppose we are taking some number like 8, 9, 2, 1. So what we do is we add 8 plus 2 and then 9 plus 1, and then we take a difference. So 8 plus 2 and minus 9 plus 1. So if this difference is either 0 or multiple of 11, so in that case we can say that this number is divisible by 11. Now how we come to this, that we can understand by the concept of remainder. So, and this remainder concept tells that any digit, suppose digit is A, B, C, D, E, F. Suppose you have to find that it is divisible by any number, say 8, or by 7, or by 11, or by 13, or so. Now what we do is we see the remainder. So if there is, this number is A, so you should add A, because there will be remainder left. This is unit place, its value is A itself. Now B is basically, its value is B into 10. Now the thing is that if you are trying to find the divisibility by 7, now it is going to be multiplied by 10. So with 7 the remainder is 3. So you will multiply this by 3. So 3b. Then go to next. Now this 10 has a remainder of 3. So after 3, if you put another 0, 30 has remainder of 2 by, when you divide by 7. So you will multiply this number by 2. Then further, if it is D, then you have multiplied by 6D, and it will go like that. You can write this like, now 6D will be same as minus D. Okay, so 6D in this case will be same as minus D, because 6D plus D, that is 7D, so it will be divisible by, so 6D is taken equivalent as D. So basically what you do is A plus 3B plus 2C minus D. Okay, and once you have gone minus D, so then again things will go like this. So minus D minus 3E minus 2F. Then further come, if there is a digit here G, so then it will go to G, and then again 3H, like that, if there is H here. So this way you can find, now you see that this is plus, and then further this is minus, which is repeating, and so that way you can have the this concept, you can use this concept. So suppose you take an example of, suppose say 875. Whether this number is divisible by 7, what you will use is, you will use this formula A plus 3B plus 2C. So it will be A plus 3B, 3 into 7, and plus 2C, that is 16, and A is nothing but 5. So 5 plus 21 plus 16, that is 42, and 42 is divisible by 7. So that is why we say that this number will be divisible by 7. Okay, so if you have further numbers, suppose you could have got something like 9, 2, 3, and then you have say 3. So in that case what you do is 3 plus 3 into 3, 9, plus 2 into 2, 4, and minus 9. So if you do that, it will be 3 plus 4, 7. So it will be divisible by 7. So this will be, we can see that you got this. Now this concept can be used for all the, numbers, whether it is 11 or 13. For 11, if you see, it will be A minus B plus C minus D plus E minus F. So that way it will go. For 13, if you go, it will be A plus 10B, suppose, and then you will go plus 9C, and so that way you will have and then it will go like minus D. So that way you can find the divisibility for the 13. So for all these numbers you can have a concept of divisibility for all these numbers. So hope you practice and you try to have more and more practice. You will have, this is a new concept which you will understand, and you can have your own algorithm. You can write even a computer programs to know whether a number is divisible by any numbers. That this rule can be used for checking the divisibility even for larger numbers. So we will have the practice on this where it will be more clear. Thank you very much.